4 is asking us to find how much of that area of the shaded region. That's called the sector. And we have an incredibly accurate circle drawn. And that center point is T, and we've got something like this that's UV. And 80 degrees. So I can point at it, they give you the radius. Instead of just finding out the part of the circumference, we're asking for the part of the area. So what do you think we're going to do with 80 again? Divided by what? Which is the area of the entire revolution, right? If we go all the way around. So we're going to have 80 divided by 360. And we're going to multiply that by, well, gee, not if we had the whole circumference, 2 pi r, but we had the whole area of the circle. Because we're talking about area now. What's the formula for the area of a circle?
Pi r squared.
Again, from elementary school, it's pi r squared. And we're just going to use it. Did they give us a radius?
Yep.
Yes. And so that's 9. And then we just do the arithmetic. 81 pi times 80 divided by 360 gives us approximately 56.55. Showing your work, providing that answer over on the right-hand side. They're asking you to estimate the areas of those shaded regions, okay? Involving circles and sectors of circles, okay? Turn the page. Almost done. This is the most challenging section, possibly, that we did as a group outside of maybe trigonometry for you in the entire course. So this last section is asking you to find the area of regular polygon. Regular polygon. Polygons that have all the same sides, lengths the same, all the angles, all the interior angles are the same. That's what regular means. Shapes are regular. So if we look, oh, I don't know, let's try number 2. So I can do one more challenging. So just sit back. This is going to take a while. This one problem. This is the one, again, was multiple steps, more challenging problems. I'm providing it for you on video. And you'll get the YouTube link. You can find it tonight if you wish to review it. Or even before the night of the final. You can still see this video and review this again. Okay? So if we look at this shape, this kind of shape, and I'm not going to draw it very well, but it's called a regular. All these sides are the same length. Use your imagination. See that they are. All these angles are the same angle measurement interior. That's a regular. So they give you some information about that coming out from here. They tell you that this length is 15 centimeters. And they tell you this side is 17.6 centimeters. Make sure I've written the numbers down right. They want you to find the area of that entire shape. So again, reviewing what we did with this, we thought of it as a bunch of triangles. Remember? How many triangles?
5.
Since it's a pentagon. 1, 2, 3, 4, 5. We have 5 sides. We're going to have 5 triangles, all of which are the same shape. If I can find the area of one of those triangles, I multiply it by what? 5, and then I've got the area of the whole shape. So that's our strategy. That's what we're going to be doing. So if I need to find the area of one of these triangles, well, to do that, I need 1/2 base times height to find an area of one of those triangles, right? Do I have the base?
Yep.
Yeah. So I can just plug that number in, 1/2 of 17.6. Do I have the height?
No.
Do not. Height is always a perpendicular line. That's why I drew this side here. I need to find this height. Suggestions as to how to do that.
You could draw that line that you just drew. And then you'll have 15 centimeters as a hypotenuse, and then you have the 17.6 for the base.
Pythagorean's theorem.
Almost. Said correctly. I think the strategy is right, as Isaiah suggested. But if I draw this perpendicular and that's the hypotenuse, 17.6 isn't the base of this triangle.
That's a divider.
Oh, you said half?
I said half.
I'm sorry. So if you did that, if you halved it, you would get whatever you get when you half it. You get 17 divided by 2. adding another 16, I think it's 8.8. Check my arithmetic there. So from this side, this base of this littler triangle is 8.8 centimeters. And now I've got a right triangle that I can use what to find the hypotenuse? Pythagorean's theorem. Is that legit?
Yes.
Absolutely. Okay? With some of the other problems, you might want to use trigonometry, which you have a working understanding and use of. But since you said Pythagorean's theorem first, I would find this height by taking 15 centimeters and doing what with it? Squaring it. Then what am I going to do with squaring the other side?
You're going to subtract it.
I got to subtract it because that's one of the legs. This is the hypotenuse, it's one of the legs. So I'm going to square that and subtract that from 15 squared. And that's not the way I did this here. But, so I don't have it in my notes. Can somebody do that arithmetic for me? So we can write it up on for the video.
225.
225 minus something.
86, or, no, I put 8.
8.8 squared.
77.44.
Subtracting that. Pass through.
It's 147.56.
So that is the height that I would plug in here for
What'd you
that
square root that?
triangle. Oh, did we not? You're very good, very good. So this is actually height squared. Thank you for that. And then yes, we do need to square root that. Thank you, Steve. Isaiah, square root that real quick.
12.14.
12.14.
15.
Would it round to 5?
Yeah.
So that would be the height for that particular triangle. But again, it's only this part of the triangle. It's this triangle that we're finding the area for. What do we really want? The area of this whole thing, right? So that I can multiply that by 5. Right? Because that's where we're all the same. So formula says take half of this and multiply times base times height. But if I want the whole triangle, what do we know about this part of the triangle, how it compares with that part? Exactly the same, right? So instead of halving it, we really want,
Just double it.
yeah, so doubling half would be 1. So if I just multiply those numbers out now, I would have the area of this entire triangle. Do that for me, please. Or actually, I think I have it right here. Go ahead and do that so you can confirm what I did previously. You get approximately 106.5. If you multiply these. No?
So wait. So after you get approximately 12.85, you multiply it by the base, right?
17.6.
Yeah, this is why this is one of the more difficult ones, because we're having base that we're calling bases of two different triangles, the littler triangle and the bigger triangle, so it can get confusing. We want to find this entire triangle area. When we did Pythagorean's theorem, we only found this, used this base, the 8.8, to find the height side of this leg. We're calling the height of this big triangle.
I got 106.92.
Okay, so it's close. I mean, I use trigonometry, so I got a little more accurate than you. But because you use Pythagorean theorem, it's okay. We're in the same ballpark.
Oh, I see. Okay.
Okay?
Wait, so how'd you get 106.5?
Because he like divided the 360 by 5 and then used that to find.
Gotta double check my arithmetic now. So again, we want, this is the height. This is the base that we use, 8.8. What I want to do is use the whole base all the way across.
That's what I was missing.
So if I go half of that base, which is 8.8, times 12.15, I should get something really close to 106.5.
I got
Did you-
106.
Isaiah confirmed that, right?
Yeah.
106.6, okay?
Yeah.
Well, if that's the area of one of these triangles, What do we do to get the rest of them?
Multiply it
Multiply
by
by
We
5.
multiply the whole thing by 5, because there's 5 of them. So that's the area of 1. If I multiply this by the 5 triangles that we have, because it's a regular shape, all the triangles are congruent, we multiply that out and we get approximately 532.4. Again, we're rounding with different levels of accuracy. So that is how you find the area of a regular polygon. Sometimes, and some of the problems they're going to give you though, we use Pythagorean's theorem here, you could have used trig, and I want to mention that, trigonometry. Because we could have taken this angle, and how we do that is, we know we've got 5 of those interior angles. 360 divided by 5 gives me the degree measurement of one of those interior angles, that pentagon. Okay, 5 into 360 gets us gets you whatever, gets your interior angle, and then you half that.
Get you 72.
Okay, and half of that gets you this angle right here, 36. And then you've got a right triangle in which you can use trig to find that height side. Okay, so I'm not going to do that as an example, but you need to be refresh your memory on that strategy, because sometimes you may not be able to use Pythagorean's theorem based on what they've given you. Okay, you may have, like, look at number 3. Well, no, you can still use Pythagorean's theorem. So any of those strategies that will work, feel free to use it. This is when we get to a part of the course where we've got lots of stuff we've learned this year, right? And by the way, have you learned a lot of things?
Yes.
Okay. So you can use a lot of any of those things to solve a problem. Be critical thinkers. Be self-directed. Knowing that you have lots of things in your tool belt to relate to. Okay, the last problems 4 and 5 out of this section. I'll just go ahead and do 4 for you. Gives you a probability. Remember when we did our games that you created? What's the probability of landing in that shaded region? You take the area of success and divide it by the total area possible. Well, it's a random selection, but you've got to land in the bigger circle. What's the chances of you landing in that littler circle? Well, you take the area of that small circle. Okay? You're going to take pi r squared of the little circle and divide that by pi r squared of the big circle. You understand my symbolism I'm using here? Okay? So that little circle, we've got a radius of 3. 9 pi. In the bigger circle, we have a radius of what? 8. 64 pi. 8 squared. You follow me, right? 8 squared and 3 squared. All you do is divide these out now, and that's your probability. 9 divided by 64 gives you your probability. You can write it as a decimal, or you can write it as a percentage, either way. Okay? So that's the last lesson in this chapter I'm reviewing with you. Ladies and gentlemen, that was your Chapter 11 review. Make sure you get your quizzes in due Wednesday along with your videos. Refer to this video for future practice. Thank you for your attention. In the future, for YouTube, those can be 15 minutes.